Considering the fact that asteroids collide with our planet every 50 to 60 million years, and the fact that the last major asteroid impact was 66 million years ago, the Earth is overdue for another cataclysmic event. When large objects impact terrestrial planets such as Earth, there can be significant physical and biospheric consequences. Though atmospheres mitigate many surface impacts through atmospheric entry, and that's why we observe so many impact craters on the lunar surface, because the Moon has no atmosphere. But even our atmospheric protective shield is no match against the size of killer asteroids. When an asteroid of only a few kilometers in diameter collides with Earth, it releases the energy of several million nuclear weapons detonating simultaneously. It is generally accepted that dinosaurs became extinct around 66 million years ago after a 10-kilometer wide asteroid hit the area which is now the Gulf of Mexico. A widely accepted theory is that worldwide climate disruption from the event was the cause of the Cretaceous-Paleogene extinction event, a mass extinction in which 75% of plant and animal species on Earth became extinct, including all non-avian dinosaurs.
One reason why we should go into space is because you know the dinosaurs would have if they could have. 65 million years ago, the Yucatan Peninsula, a rock the size of Mount Everest slammed into Earth, and it changed the climate of the world, rendering 70% of all species extinct. The dinosaurs are just the ones with the biggest teeth that we remember most, but that was a bad day on Earth. And the dinosaurs don't have opposable thumbs, they didn't have a space program. I'm thinking if they did, they would have deflected that asteroid. I just imagine a conversation with an alien. And I say, I don't want to be the laughing stock among the galaxy's aliens, to be a species intelligent enough to have a space program, to have actually gone into space, yet to go extinct because an asteroid came and we couldn't mobilize and figure out how to deflect it. We'd be the laughing stock of species in the galaxy, the extinct humans.
NASA scientists have proposed a variety of strategies to deal with asteroids that pose a threat to life on Earth. Deflecting an asteroid would probably require 2 space missions. The first mission would send a robotic probe towards the asteroid to knock it off course. The second mission would be a follow-up to launch a gravity tractor spacecraft to fly alongside the asteroid to nudge it further away by using gravitational tug. However, such a strategy would probably only work on asteroids up to 400 meters wide. Larger space rocks would require several impacts from probes or attempts to destroy the asteroid with a nuclear bomb. Unfortunately, the latest simulation exercise shows that even a nuclear bomb wouldn't stop a giant asteroid headed for Earth. In a simulated exercise, US and European scientists were told they had 6 months to come up with a life-saving plan to stop a massive rock smashing into Earth that had been spotted 35 million miles away. The simulation taught the group a difficult lesson. If an Earth-bound asteroid were spotted with that little warning, there's nothing anyone could do to keep it from hitting the planet. The experts determined that no existing technologies could stop the asteroid from striking, given the scenario's 6-month window. There isn't a spacecraft capable of destroying an asteroid or pushing it off its path that could get off the ground and fly to the rock in that amount of time. It turns out we'd need 5 to 10 years. And that's why it's utmost important to have an advanced space program. Not only would it ensure the survival of our species from killer asteroids, but it would be extremely lucrative.
So the farthest we've been is to the moon. It's nothing compared to the planets and the rest of the stars. So the space is a frontier, but there's some practical reasons, I think. I want to go because it's cool and you discover stuff. But there's some practical reasons that I think should not be overlooked. Yes, you want to be looking up if the asteroid is going to come and take us out so that you would deflect it. And if you live in an innovation nation where people are scientifically literate, whether or not you are a scientist, you want to be around people who will, upon learning there's an asteroid headed our way, what's your first reaction? Well, whatever you need to run, you can run, or you can say, how can I deflect that? You want people around you who are thinking that way. And so space can render us extinct because The universe is one of the greatest killers of life. But also, the innovations necessary to perform all of this, I think they can affect a culture in a way that turns everybody into people who think about tomorrow. The day you stop thinking about tomorrow, you stop innovating. Why else would you innovate? Oh, sure, you can innovate because you want to make a buck. I got that. But if your best innovative thought is what next app I can put on my smartphone, rather than tackling huge challenges that face our civilization today in transportation, in energy, in health, in security. These are major branches of our civilization that I don't see us giving attention to. And if you go into space where your health, energy, security, safety, all of these are frontier issues. If you're advancing a frontier, this stuff just rains out of the sky as things that contribute to where we are in our civilization. And so space exploration is a long-term investment on the health and wealth of a nation.
As resource depletion on Earth becomes more real, the idea of extracting valuable elements from asteroids and returning these to Earth for profit, or using space-based resources to build solar power satellites and space habitats, becomes more attractive. Most of the metals we use in our everyday lives are buried deep within Earth. When our planet was still molten, almost all of the heavy metals sank to the core, which is pretty hard to get to. The accessible veins of gold, zinc, platinum, and other valuable metals instead came from later asteroid impacts on Earth's surfaces. Those asteroids are the fragmented remains of almost planets, but they contain all of the same mixtures of elements as their larger planetary cousins.
The first trillionaire in the world is going to be the person who first mines asteroids. Space did a lot of filtering for you. There are asteroids that are the core of planets that never fully formed and broke apart. But the planet, while it was trying to get underway, it was liquid, fluid, and when you're liquid, heavy things fall to the middle and light things rise to the top. Then you freeze. The geologists call it differentiation. So you get for free the heavy stuff in the middle. Break that all apart, reach in, grab the asteroid that's made of the middle stuff. You know what's in that middle stuff? Gold, platinum, iridium, iron, nickel. All the stuff that people have fought wars over, that are tracked on the stock market, that we use in industry. So yeah, that's the first trillionaire right there.
Asteroids could one day be a vast new source of scarce material if the financial and technological obstacles can be overcome. Asteroids are lumps of metal, rock, and dust, sometimes laced with ice and tar, which are the cosmic leftovers from the solar system's formation about 4.5 billion years ago. There are hundreds of thousands of them, ranging in size from a few yards to hundreds of miles across. Small asteroids are much more numerous than larger ones, but even a little, house-sized asteroid could contain metals possibly worth millions of dollars. There are different kinds of asteroids, and they are grouped into three classes from their spectral type, a classification based on an analysis of the light reflected off their surfaces. Dark, carbon-rich C-type asteroids have high abundances of water bound up as hydrated clay minerals. Although these asteroids currently have little economic value since water is so abundant on Earth, they will be extremely important if we want to expand the human presence throughout the solar system. Somewhat brighter asteroids have a stony composition. These S-type asteroids have very little water, but are currently more economically relevant since they contain a significant fraction of metal, mostly iron, nickel, and cobalt. Currently, the quality of ore and the consequent cost of massive equipment required to extract it are unknown and can only be speculated. Some economic analysis indicate that the cost of returning asteroidal materials to Earth far outweighs their market value, and that asteroid mining will not attract private investment at current commodity prices and space transportation costs. Other studies suggest large profit by using solar power. Potential markets for materials can be identified and profit generated if extraction cost is brought down. For example, the delivery of multiple tons of water to low Earth orbit for rocket fuel preparation for space tourism could generate a significant profit, It currently costs hundreds of millions to billions of dollars to build and launch a space mission. So, innovations that would make these costs fall dramatically are needed before it is profitable to mine asteroids for the value of their metals alone. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.